Tonight's lesson 9.8 is on volume of rectangular prisms. So far we've been talking in this chapter about finding area of shapes. And area, as we know, is two-dimensional. So if I look at this square, for example, oops, let me grab a pen. I look from here to here. I go 1, 2.5. This would be the base. And then the height is right here, 1, 2.5, and since it's a square, same measurements on all sides. Okay, so we could say that the formula for the area of any rectangle is going to be base times height. And then we talked about in class today, if I take that square and I just chop it directly in half, I get two triangles. And what I can see right away is that, let me pick a different color. Let's see, let's go with blue. If I look at this right here, I can see that the base and the height are exactly the same for this triangle, and yet I know right away that this right here is not taking up the same amount of space in terms of its area as the square is. So based on that, and we came up with each and every time, if we had the same measurement for the base and the same measurement for height of a rectangle and the triangle, we came up with the formula for a triangle. And I'll just put triangle right here so we know that's what we're talking about. That the formula for the area of a triangle, we could write it in two ways. We could say 1/2 times base times height, or we could say, here's the other option, say or base times height divided by 2. And I'm just going to make sure we know over here that this is the formula for rectangles. Okay, so this is all area, but now today we're going to be talking about something different, and that's volume. Volume is always going to be three-dimensional, and that's what makes it different from area. So we're really talking about not just finding the area of one side, but actually all of the space. Oops, undo that. We're talking about everything that's inside here. What can fill up the space inside this three-dimensional container? And in this case, it's a cube. I'm going to extend the page so I can write down below it. And the way we go about doing that is we're first going to figure out what is the area of the base. And just like when we were talking about two-dimensional, and we're talking about area, we say the base is the side that it sits on. Well, the same is going to be true. Instead, it's the face, because we can see that this cube has 6 faces. It's just another name for the sides. So whatever face it sits on, we're going to refer to that as the base. So in this case, we're going to calculate first what is the area of the base, and then we'll multiply it times the height. Okay, so down here, this is the area of the base. And so the way we write that, we're looking at this, and remember earlier we were talking about this two-dimensional, finding the area. You could say base times height. Another way you could say that is length times width. So sometimes when you'll see the formula written like this for the volume of a prism, you'll see length times width times height. You're just going to multiply all 3 dimensions together, and that's how you come up with the volume. But another way to think of it is, and this will apply to more than just the rectangular prism, is the area of the base, which we're going to call that big B. Okay, area of the base. I'm going to write what that means. Area of the base times the height. So looking at this one right next to it, we have another rectangular prism. Let's just say, let's give this the dimension. Let's say this is 10 centimeters. This side right here is 3 centimeters. And then right here, let's say 5 centimeters. So using our formula, that is volume equals big B, which means area of the base times height. Let's go ahead and plug that in. So volume equals, and if I want to figure out what is this the area of the base, that's the face that it's sitting on, it's going to be 10 times 3, which is 30. So we'll plug in 30, and then the height is 5. So I can say that the volume, 30 times 5, which is 150, so it would be 150, and this is where we're going to use a different unit. We're going to say centimeters cubed this time, and that's pointing out for you that it's three-dimensional. So what if you have an irregular shape like this one? So it isn't really a rectangular prism, and you want to figure out the volume of this. So just like when we were trying to figure out irregular shapes in 2 dimensions, we can chop this into rectangular prisms and then solve for it. So let's do this. Let's grab a different color. And what could we do here? We could draw an imaginary line right here and draw an imaginary line right here. We can calculate the volume of this part right here, this lower part, and then we can calculate, so let's call this part A, and let's call this part B. And so remember, we're talking about 3 dimensions now, volume. So let's start with the bottom part. And if you remember, we're talking about the formula for volume is big B, area of the base, times the height. So let's look at this. If I look at the part it's sitting on, and let's see, I think I may have missed giving you one thing you need to know. And that is, yes, I need to give this to you. So this right here, let's just say this is equal to, let's say, 12 centimeters, meaning L right here, from this point to this point. Okay, so now we're looking at a formula. The volume is area of the base times the height. So I'm going to look at the part it's sitting on, and I'm going to calculate that the area of the base is 10 centimeters times 12 centimeters. So I have 120 centimeters times, and I look at the height, and remember, I'm trying to figure out just this part on the bottom. We sort of chopped off this little extra part. So instead of writing 10 in here, I'm going to look at how tall it is from this point to this point, because that's going to be the height for this bottom chunk that we're calling A. So let's call that 7. So we can say that the volume of that bottom part is 840 cubic centimeters. So we figured out the volume for this. So this is, I'm going to put this in a different color. So this is A. We just figured out A right here. All right, so now we're going to move on to figuring out B. So for this B section, I'm going to do the same thing. Maybe I'll write it over here. Volume equals big B, which means area of the base times height. And let's just plug in our numbers. So if I look at this, I'm trying to figure out, well, this is the part it's sitting on. Okay, so what is the distance from this point to this point? Well, I can look at it right here and see that from here to here is going to be the same as from here to here. And so I already know that's 3. So 3, and then this is the same length as it is here, so it's going to be 3 times 12. So I'm going to say the area of that base, 36 times, and then the height. How would I figure that out? If I know that from the very top part of this whole figure to the very bottom is 10, and I know that from here to here is 7, then this part must be 3. So I'm going to say 36 times 3. So the volume of that section is going to be 108 cubic centimeters. Okay, so this part that we just figured out is B. And now that we have A and B, we can just add them together. So I'm going to just write it down below. I have 840. This represents A, plus the 108 that represents B. Let me see if I can extend my page a little bit. There you go. And I just add those up. And I end up with the total volume is going to be volume equals 948 cubic centimeters.